All right, so let's continue with the applications of Newton's law. Okay, now the very first applications of Newton's laws is the body on elevator, a body on elevator or a body on a lift. Okay, so now before we start with the body, a body on an elevator or a body on a lift, now you guys need to know this first. Now let's say, for example, let's say you placed a block or an object in a table. There's usually this downward force that usually acts on the table, trying to collapse the table, right? Yes, but the table will not collapse because why? The table also exerts a resistant force. The table itself will exert what? This is the table, this is the block. The table will exert what? A resistance force opposite to the weight. Okay, so this resistance force is an upward force, and this resistance force is known as the normal reactional force. Okay, normal reactional force. Okay, to represented by capital letter N. Okay, so it is this force that prevents the table from what? From collapsing as a result of the weight of the block. Now, if you look at this system, how many forces acting on this system? It's usually two forces, right? So the total force, please take note, the total force acting on this system is equals to what? The normal reactional force, then minus what? The weight. Now the reason why there is minus here is because why? Weight is going what? Is going downward, right? Remember, according to the coordinates, going upward is positive, going downward is negative, right? So the weight acting downwards towards the negative y-axis. So this is why it's negative. Okay, yes. Now the total force acting is equals to what? The normal reactional force minus what? Minus the weight. Now, is the block moving? No. Since the block is, remember, force is equals to what? This is total force. So force is equals to what? MA, right? Force is equals to MA equals to what? Newton. Equals to normal reactional force minus weight, right? Now, since the block is not moving, that means that the block acceleration is what? Is zero, right? So therefore, the acceleration here will be zero. 0 times mass will still give us 0, right? So everything here will be what? Everything here will be 0 equals to what? Normal reactional force minus W. Yes. So if this minus W come to this side, it turn positive, right? So it now be what? It now be W equals to what? N. So this is the reason why the table is not collapsing. Because why? Because there's a balance. Because there's a balance between what? The resistant force of the table, which is known as normal reactional force. There's a balance between the resistant force and what? And the weight. Okay. So if the weight, had it been the weight is greater than the normal reactional force, the table would have collapsed. Okay. So take note of this. It's very important. Okay. Now let's go back to body on what? Body on an elevator. Yes, a body on an elevator or a body on a lift. Now there are usually three scenarios we are going to take note of. Okay. Now let me start with the very first scenario. Okay. Now let's start with this very first scenario. Now let's say a body is on an elevator and the elevator is not moving. That is why you find out that acceleration here is 0 when the elevator is not moving. Now what is the reading of the scale of the elevator? Now when the elevator is not moving, now if you look at this scenario here, let's say the man is standing on what? The man is standing on the elevator, right? Yes, according to what we did previously just now, reactional force. Now there is this there's this upward force exerted by the floor of the elevator, right? Yes, that force is known as normal reactional force, right? It's an upward force. Apart from that one, the person in the elevator exerts what? A downward force known as what? The weight, right? Yes. Now let's continue. So that is why you see something like this, N and what? W. Okay. So now the total force acting on this system, how many forces acting on this system is what? Is 2, right? Yes. So the total force is equals to what? The normal reactional force, which is going upward, minus what? Weight. You know why weight is negative? Because it's going downward towards negative y-axis, right? So minus W. Now in this condition, when the elevator is not moving. See, when the elevator is not moving, the acceleration is what? Zero, right? So total force, what is the formula for force? Formula for force is what? MA, right? Equals to what? Normal reactional force minus W. So since the acceleration is zero, everything here will be what? Everything here will be zero, right? So now be zero equals to what? Normal reactional force minus W, right? So if minus W come to and towards the other side, now be what? W equals to what? Normal reactional force. Okay, so during this scenario when the elevator is not moving, the scale, please take on, this is very important. The scale will read what? The scale will read a weight that equals what? That equals to the true weight of the what? Of the body. Let's say for example the weight of the man is what? Is 50 Newton. Let's say the weight of the man is 50 Newton. The scale will still read what? 50 Newton. Because why? Because the acceleration is zero, the elevator is not moving. Okay, so the reading of the scale will equals to what? We equal reading of the scale, please take note. Scale reading, the scale reading, or you can say the scale reads the true weight of the body, the true weight of the body in the elevator. Okay, so if they ask you when the elevator is not moving, what is the scale reading? The scale will read what? The scale will read what? The true weight of the body. Okay, yes, that is when the body is not moving. Okay, now what about when the body is moving? Now when the body is moving downwards, it has an acceleration. The second scenario. Now I've talked about this in the first scenario when the body is not moving. Okay, yes. Now when the body is moving downward, when the body now has an acceleration and it's moving downward, what is the reading of the scale? Now let's do it. Remember, total force, how many force is acting here is 2, right? Total force acting on this system is equal to what? The normal reactional force minus what? Minus the weight, right? Now since it has an acceleration, it has an acceleration, and apart from that one, the acceleration is acting downward. What does this mean? It means that when the elevator is going down, I don't even understand. When the elevator is going downwards, that is, the acceleration is negative. When the elevator is moving down, okay, yes, it has negative acceleration. You know where? The acceleration is what? Acceleration is negative. You know where? Because we are going downward, is always negative. Right, going up is what? It's positive, right? According to the coordinates in vector. Okay, going down is negative, going up is positive, right? Now, when a condition where the elevator is moving downward, remember, moving downward, its acceleration will be negative, right? So let's continue. Moving downward, it has what? It has an acceleration, right? And that acceleration is what? Minus a, right? Equals to normal reactional force minus what? Minus the weight. M times minus a will give us minus ma, right? Equals to normal reactional force minus what? W. Okay, now let's continue. Now if they ask us what is now the scale reading? Now let's say we take this side to this place. You don't, if minus W, if it crosses this equal to sign and goes to the other side, it will turn what? If it turn positive, right? So everything will now be what? Everything will now be W minus MA equals to what? Equals to normal reaction. I don't know if you understand. The reason why W becomes positive because it crosses the equal to sign and goes to the left hand side, right? So this we end up with something like this. Okay. Now, if they ask you what is the reason of the scale when the elevator is moving downward? When it's moving downward, the acceleration is negative because going downward is negative, going upward is positive, right? So when the elevator is going downward, the scale reads a weight lesser than the true weight of the body. I don't know if you understand. The scale will read what? We read a weight lesser than the true weight of the body. Yeah, I don't know if you understand. Now, it is this scenario where the body become weightless. I don't know if you understand. The body will feel light. So it's when the elevator is usually going down. If you have entered an elevator, you find out that when the elevator is moving down, you will feel light. You feel a sign of weightlessness. Okay, this because let's just do it practically. Now let's say the weight of the man normally is 50. I don't know if you understand. Let's say the weight of the man is 50. Let's say the mass is 5, and the acceleration is let's say the acceleration is okay. Let me say the weight of the man. Let's say the weight of the man is 60. For example, the weight of the man is 60. Then the acceleration is 10. For example, okay, 5 times 10 will give us 50, right? Give us 50. So so 60 minus 50 will give us what? Will give us 10. So you find out that you will become like you feel weightless. I don't know if you understand. So so the scale we read what? We read the weight. The scale we read what? We read the weight lesser than the true weight of the body. Normally the true weight of the body was 60, right? Yes. But when the elevator starts going down, the weight of the body now becomes what? 10. So this is why when the elevator is going down, you usually feel light. Yeah, you become light, you become weightless, okay? Because why? Because during this process, the scale will read what? Please take note, the scale read a weight lesser than the true weight true weight of the body okay. So let's continue. Okay, so let's continue because there is usually calculation in all this in this aspect. Okay, so now normally what is weight is what? Weight is mg, right? Formula for weight is mg, then minus what? Ma is equals to n. Okay, since mass is common in both sides, now we will bring out m equals to bracket g minus a bracket close equals to n. So in everything will now be what? Everything now be the scale everything now be what? N is equals to what? M bracket open G minus A. Okay, so please take note of this formula. Okay, so this is the formula we are going to use whenever the elevator is moving downward. Okay, please take note. When the elevator is moving downward, this is the formula we're going to use. M bracket open G minus A bracket close. Okay, so that is it. Okay, now the last category, the last scenario, when the elevator is what? Is moving upward. Okay, when the elevator is what? Is moving upward, what will be the scale reading? Now when the elevator is moving upward, it has what? It has an upward acceleration, right? Now remember, going upward is what? Going upward according to the first coordinate, going upward is positive, going downward is negative, right? So since the body is going upward, it has what? It has a positive acceleration. Now let's look for the total force. How many force is acting on this system? Usually two, right? So the total force acting on the system is equals to what? The normal reactional force, which is acting upward, minus the weight, which is acting downward. Now force, what is the formula for force? Normally force is what? Na, right? Now since the acceleration is positive, so that is why you didn't see anything negative here. It will be what? It will be m times what? Positive a, which is still same as what? Ma. I don't know if you understand. Positive, okay, is equals to what? N minus W. Okay. Now, if you make this normal reactional force to stand alone, taking this one to this other side, we have something like this. We have we have something like this. Ma plus W is equals to what? Is equals to N. Okay. So now, during this scenario when the elevator is moving upward, the scale will read a weight greater than the true weight. I don't know if you understand. Let's say the true weight of the body was 60, and the acceleration was 10, and the mass is 5. So 5 times 10 give us 50, right? 50 plus 60 will give us 110. You find out that during this scenario you will become heavy. I don't even understand. This is because because of the addition of what? Of Ma to W. I don't even understand. So please take note. When an elevator is moving upward, the scale we read what? We read the weight. We read the weight greater. We read the weight greater than the true weight of the body. Okay, than true weight of the body. So during this scenario, you will become heavy. And if you enter an elevator and the elevator is moving upward, you become what? You become heavy. You feel heaviness. I don't understand. Okay, so this is because why the scale because why? Because the scale is moving upward, and because why the acceleration is positive. Okay, so you see it here. Okay, so that is just it. Okay, now let's continue. W is what? Mg, right? Plus ma equals to what? N. Okay, if you continue here, since m is common on both sides, we take one of the m. N equals to what? We take one of the m, bracket open, a plus what? A plus g, right? So this is the formula we are going to use when they ask us to calculate for when the elevator is moving upward. Okay, so whenever if they ask us to calculate for anything, this is the formula we are going to use. Okay, when the elevator is moving upward. Okay, so that is just it. So important things you need to take note of in summary to a body on in a lift or a body on an elevator is that the summary is that when the elevator is not moving at all, the scale will read what? We read the true weight of the body, right? Read the true weight of the body when the elevator is not moving. Now, when the elevator is not moving, it's moving downward. The scale we read the weight. We read the weight. We read the weight lesser than its true weight, right? Yes. We read the weight. We read the weight lesser than its what? Let me. Okay, I'm coming. We read the weight lesser than what? The true weight of the body, right? Yes. Now, when the elevator is moving upward, the scale will read what? We read the weight greater than what? Greater than its true weight. Okay. During this scenario, you become heavy. During this scenario, you feel weightless. Yes. Become light. Feel like weightless. Okay. So these are the things you need to know about under a body on elevator. Okay. So now let's do some calculations under this. Okay. Now remember, when the body is going downward, the formula we're going to use would be, if I'm not mistaken, m bracket open g minus a. Yes. Then when the body is going upward, we are going to use m bracket open a plus g, the bracket close. Okay. So yes. Now let's do some calculation questions. All right. So let's solve this question. Okay. A 10 kg box rests on a scale which is placed on the floor of an elevator. Find the what? Find the apparent weight of the bus if the elevator is A, moving with a constant velocity of 2 meters per second downwards, B, acceleration of if the elevator is moving with acceleration of 5 meters per second downwards, then C, when the acceleration of the elevator is moving with what? With 5 meters per second square upward. Okay, so they're asking us to look for what? Essentially look for what? Look for the weight, the apparent weight, okay, of the box if the elevator is what? Is moving. Let's solve this question A, okay? Now, remember that when a body is moving to a constant velocity, you know what that means? It means that the body does not have an acceleration. It means that the body is not accelerating, okay? It means that the acceleration of that body is what? Is zero. I don't know if you understand. So be careful in your question. If you say in a particular question, like question like this now, for example, when they said that the elevator is moving with a constant velocity, I don't even understand. So be careful. When the elevator is moving with a constant velocity, it means that the elevator is not moving at all. It means that the acceleration is what? Is zero. Okay. So I gave you guys three scenarios, right? When the elevator is not moving, when the elevator is moving downward, and when the elevator is what? Moving upward. Now, when the elevator is not moving, what is the weight of the body? I don't understand. Remember, when the elevator is not moving, the scale read what? Read the true weight of the body, right? Yes. So let's solve now. We are looking for what? We are looking for the apparent weight, right? We are looking for what? This guy, okay? And when the elevator is not moving, the scale will read what? Read the true weight of the body, okay? So what is the mass of the body? The mass of the body given to us was is 10 kg, right? It's 10 kg. Now, what is weight? We know that weight is what? Weight is mg, right? So n will be equals to mg. N will be equals to what? M is what? 10. 10 times what? G is what? G is 10, right? G is 10. So everything will now be what? 100, okay? So everything will be 100. So the scale we read the true weight of the body. And what is the true weight of the body? The true weight of the body is what? Is 100 Newton. So the scale will read 100 Newton. Okay? Because why the elevator is not moving. When the elevator is not moving, acceleration is 0, and what? And the scale we read what? We read the reading on the scale equals what? The true weight of the body. And here, where is it? Where is weight of the body? Weight of the body is 100, right? So the apparent weight of the bus, if the elevator, everything will be what? Everything will be 100. Okay. So let's do question. Let's do part B. Okay, let's do part B. Now, when the elevator is moving downward with a acceleration of what? Of 5 meter per second square. I gave you guys particular formula, right? I said that when the elevator is moving downward, the scale will every n will equals to what? Equals to m bracket open g minus a, right? Yes. So we are looking for n, which is the apparent weight or the scale reading, which is equals to what? The mass is what? 10 kg, right? 10 bracket open. G is 10. Okay. Then minus what is the acceleration? The acceleration is what? 5, right? So 10 minus 5 will give us 5. Then 10 times this 5. 10 times 5 give us 50. Okay. So the scale reading will be what? The scale reading will be what? 15 Newton. Okay. Very easy. The body, remember the true weight. What was the true weight of the body? True weight of the body was what? Was 100 Newton, right? Yes. Now when the elevator is now moving down, the weight is now what? Is now 50 Newton. Find that the body will now become light. Okay. So when the elevator is moving upward with an acceleration of what? Of 5 meter per second square. I gave you guys the formula when the elevator is moving upward, right? So when the elevator is moving upward, m will equals to what? M bracket open a plus g, right? Yes. So n will equals to what? The mass is 10, then bracket open, and the acceleration is 5, then plus the g is 10, right? So 5 plus 10 will give us 15, right? So you to be 15. 15 times 10 will give us what? 150. So the weight will now be what? 150 Newton. Okay. So the scale will read what? We read a weight of 150 Newton greater than its what? Than its real weight. Okay. Remember, when the elevator is moving upward, the scale we read the weight greater than the true weight of the body. Remember, the true weight of the body was 100, right? So when the elevator is now going upward, it's now read what? 150 Newton. So that's to tell you that the body will become heavy, or you will feel heaviness when the elevator is moving upward. Okay. So now let's move to the next applications of Newton laws, which is motion of connected particles. Okay.